So we have a problem from 1.4, problem number 44. It's got an asterisk beside it because this problem is not exactly 44 in the book. So I just changed the numbers around just slightly so you just can't copy the answers. But this one is solving a quadratic form equation. And what that basically means is these types of equations are not quadratic like you normally see with like ax squared plus bx plus c equals 0. But the commonality there is that the degree on this one is twice this one. So this one's 4 and this one's 2. So they work very similar to the other ones. And we solve these by substitution. And in my classes, I use the symbol delta. If you've had another class, they may have used something called a smiley face or some other symbol. But I like using the delta. And it's a little triangle. That's all it is. So and what I always let my delta equal to, this is how I teach my students, is you let delta be equal to the middle term, in this case negative 5x squared, except you don't include the negative 5. So you use the middle term without its coefficient. So in other words, the expression x squared. And then I let delta squared be the first term without its coefficient. Well, there is no coefficient other than a 1 anyway. So in this case, it would be x to the fourth. So you take this equation and replace the terms in the original equation and replace those with the deltas. So the x to the fourth becomes delta squared. The minus 5x squared is a minus 5 delta. And then a minus 14 equals 0. So even though these deltas are not x's, but it does now look like a normal quadratic equation, except you're not using x's, but you're using deltas. So you solve this equation for delta like you normally would do. In this case, it does factor. And so it's a delta minus 7 times delta plus 2 equals 0. And that's how it factors. And so delta would be equal to 7, and delta would be equal to negative 2. Now, you probably at this point could realize why we're using these weird symbols like a delta or a smiley face. It's because if you're using normal letters like a Y or a P, you're very likely to leave it alone, because if you said Y equals 7, Y equals negative 2, for you guys who has kind of limited solving equation, you would think that's normal and go on. And you would say, well, Y equals 7, Y equals negative 2, and go to the next problem, not knowing that you just missed a problem. Okay, I made no mistakes, but I'm just not done yet, is what it is. So delta is 7 is not where we stop. We have to continue. So delta is the same thing as x squared. So what we do is we go back and put our original variable back in, because that's what we want to solve for, is the original variable. So x squared equals 7 and x squared equals negative 2. So it's kind of like a temporary storage unit is basically what I call it. So I have a computer science minor, and so it's basically, it's a substitute of one unknown for another. So, but anyway, so it's x squared equals 7 and x squared equals negative 2. So now isolate the x's, and we learned this back in 1.2, something called the square root property. And so x is equals to plus or minus the square root of 7, and x equals plus or minus the square root of negative 2. Now, the negative 2 is inside the radical, so we need to get rid of that negative by taking an I. And so that's going to be plus or minus the square root of 2 times the square root of negative 1. That's what negative 2 is. Square root of negative 2 times square root of negative 1. But square root of negative 1, if you remember, is called the I. It's the imaginary unit. So it's the square root of 2 times the I. Just make sure the radical doesn't extend past over the I. That's something totally different. That's why some people choose to put the I prior to the square root symbol instead of where I have it right here. I like it this way better because I'm pretty neat, and so I'll keep it that way. So there's 4 answers: plus square root of 7, minus square root of 7, plus the square root of 2i, minus the square root of 2i. And so this is one form of solving a quadratic equation by substitution. So in your homework, there'll be quite ones that are much different from this one, but their process is the same. You let the delta be the middle term without the coefficient, and you let the delta squared be the first term. So I'll get you started on one other problem. I won't do it in this series here, but I want to show you that this problem can be relayed to a different type of a situation. So if you had 3x plus 5 to the second minus 5 times 3x plus 5 okay, and minus 14 equals 0. So this problem right here, you're like, well, that doesn't look like this one, but it is, because you got the same coefficients. You got 1, -5, and -14. 1, -5, and -14. The coefficients are the same. The 4 here, 2 here, that doubles. 2 here, 1 there, that doubles. Now, what some people like to do here is to go ahead and multiply this out, and you can do that, and you get the right answer, but you're not solving by substitution. So I'm going to keep it consistent with what I'm doing here. So what I'm going to do is let delta be equals to the middle term without its coefficients. So in this case, it's 3x plus 5 because it's without its -5. And then the delta squared is equals to 3x plus 5 squared, the first term without the coefficient here of the 1. So now when you put those back in, you substitute those back in, you get delta squared replaces this, okay? The -5 times the delta replaces the 3x plus 5, drop down to -14 and the equals 0. And if you notice, right here, this is the same thing as this right here. So you solve for delta very similarly. Except when you go back in, you won't be putting x squared back in for deltas. You'll be putting back in 3x plus 5 back in for your deltas once you solve for the deltas. So it's works. The process is exactly the same. So so this concludes the 44 problem, section 1.4. So thank you.